So I'm going to put a line of screws along each edge here, here and here and here, between the posts. And I want them about where the top of the posts are. So I want to draw a line across here to show me where the top of the posts are. And one way to do that is, if I get my little bit of wood, I'll just take that, put that there, and just run a pencil underneath. Get a straight line, just do the same here. And then on these ends. One more. So there's my line. Okay, now I need screws every few centimetres. I think I might do, let's just mark it here in the middle. So one in the middle, and then, yeah, then one there, one in that middle, and one in that middle, that middle, that middle, that middle, you see what I mean? Maybe one right on the edge. So 1, 2, 3, 4, 5, 6, 7, 8, 9 on each side. Didn't judge those distances very well, but I will do it better with the drill. It's not going to be fabulously accurate, and it doesn't have to be. I'll just mark the other side as well. So one in the middle, then half of that, one on the ends, and then one in each middle. 2, 3, there we go. That'll do. Here the same, so one there, one on each end, one on each. That's 5, and then 5 here as well. So you see, I'm not really into measuring things for this purpose. It doesn't. Sometimes there's a need for precision, should we say, and sometimes there's a need for imprecision. Now it's hard to get a screw going to start with, so I'm just going to bash these in, and then screw them in properly. This is how unfussy I am about how far up these are apart. Right, let's drill those in a bit. Not all the way. The point is they're like hooks for putting the wire on, so I don't need them to be in very much. Just enough to stick out about 1.5 centimetres, 2 centimetres. Get the angle just wrong, it really doesn't like it. Here we go. So I'll do the same on the other side and the 2 smaller sides, and then we'll get on with the wire. So now we've got screws on all 4 sides. There they are running along there. Again, even enough to do the job. And there's the ones there. So now I've got to make some wires, some pieces of wire which I'm going to loop around those screws and form a crisscross pattern. So this is, I think, 10 gauge wire. I can't remember how wide that is in terms of millimetres, but it's pretty thick stuff, and I need lots of lengths of it because I'm going to do some separate lengths, one or the other. I mean, it'd be great if I could just weave it in and out, but it's just too thick to do that with. So I have to make, I'm sure this is too thick, so by all means get something narrower, smaller, easier to manage. I'm going to measure some pieces and put a little loop on each end with a pair of pliers so that I can hook them around these screws here. So I need about 2 or 3 centimetres either side. So I'm going to do one and see if it's the right length. So I'm going to cut it about there. I've only got these to do the cutting, which is, they're not very strong, so and neither am I, so let's see how we go. There we go. So I'm just going to get this one done and see if it's the right size, and if it is, I'll know how big to make all the others. So all I'm going to do is grab it with a pair of pliers and bend it round just at the end like that to make a loop, something like that. There we go. And I'm going to bend that loop up to a right angle, and then that just hooks onto my screw. Let me just show you the other way. So it hooks on like that. So if I do that both sides, that gives me a horizontal going this way. And there's enough give, there's enough play that it will stay on. And if I just make it a little bit tighter, then it won't come off either. Like that, then it's not going to come off. Okay, so I'm going to do that at the other end as well. So bend a loop round. Then bend it to right angles, or nearly right angles, like that. Let's just check if that hooks on. Too much, it's too small. There we go, and this one. I've got a feeling I might need to tighten it in place, so let me not make it very tight to start with. A very tight loop. So it's really tough to use. It's going to kill my hands. Yeah. So something like that. So it could be a bit longer. Let's make that a bit longer. So this is going to take ages, and again, I'm sure there's a better way. There must be some kind of wire mesh, maybe. When I was a kid, we had stuff called chicken wire. You'd make chicken coops with it. That must be better than this. But I'm aiming for something like that. So there's my first piece of wire in there. It's good enough. And when I thread the other long ones through it, weave it like a basket, that'll hold this in place very firmly. So even if it's a bit loose now, I can adjust this. So I just need lots of those. Was it 9 across here? So I'm going to cut lengths 9 across, do that looping at each one, and try and make a fairly neat grid of wires, and then go and plunge my hands into warm water for an hour. Okay. Just wanted to do a close-up of how to do these little loops. So there's the end of the wire. I take my pair of pliers near the end and then just bend that up, roll it round so it's almost touching, and then I take that loop and I just bend it up at right angles like that, and that's with one at each end. That's hopefully enough to hook on there. Sometimes you've got to adjust it if it's a bit too short, so let's a bit longer, a bit longer. That's good enough. Again, when they're threaded through, when they're threaded together, they'll be a lot stronger, less liable to come off. Now let's just have a quick look at the long wires, which are going to go across there. But I'm going to thread them in and out of these others, and it's not that easy. So the first one's usually all right. So just under and over, under and over. Under, and then try and hit it, hook onto its relevant, something like that. So that one's fine, but they get progressively more difficult as you go across. In fact, let's push that one over because it's quite long. Right. So I'll do the rest, and maybe I'll show you the last one because that's always the hardest. So here's the last one being threaded through. It's getting quite tricky, and sometimes you find these things pop off the screws as well. Bit of a pain. But maybe this is why this wire needs to be so thick, just to cope with these stresses. So it's still doing under and over. Under there, so one more over the top. Up you go. There we go. Okay. I'll just get it onto its screws at the end. There we go. That'll do. Okay, that's a pretty hefty grid of wire. It's not going anywhere, especially when it's covered with plaster and set. That'll add some good strength. And someone's going to write in and tell me you don't need to do all this. The plaster will just hold itself up. But I don't know. I feel a lot more confident knowing that that's underneath when I slam a piece of clay on top. I don't want my plaster to be broken. So that's that. We're ready to go for the next stage, which is mixing the plaster and pouring it. I think I'm going to leave that till tomorrow because it's quite late at night now. So we've got the frame made up, the wood and the wire. Now we've got to work out how much plaster we need for the inside. And that's about volumes of plaster. It took me ages to find out. I looked all over the internet to see what volume of water do you need for what volume of plaster to end up with what volume in total, blah blah blah. I couldn't find a good answer, but found a very good someone at my previous studio, Giuseppe Parrinello. I'll put his link on the video at the bottom. He explained to me how to mix plaster and what proportions to use. And that was really, really useful. So thanks to him I can kind of do this. And the other thing, with the experiment I did at the first wedging table, I found out how much volume you need to, if you've got a certain volume to fill, which is where we're going to start from, then you need therefore this much plaster and this much water. And that's been really useful for me. So hopefully it'll be useful to you too. Because if you're struggling like I was, then it's a bit annoying to not know the answer to something very simple. And it turns out the answer is not very simple because it's a question of, well, what do you want to do with the plaster? There are lots of uses for plaster, and for each different type of plaster as well, you need different proportions of water to plaster. So fair enough. There are lots of reasons why you'd want this much water and this much plaster. But in our case, I think I've worked it out. So do let me know if you think it's totally wrong, but it does seem to be about right compared to if I look at my existing wedging table. So first thing is, how much volume do we want to end up with of plaster? Well, here's the area, and I just need a certain depth. It's a bit complicated because we've got these wooden posts in the way. But if you imagine, I'm doing it fairly rough and ready as ever. If I imagine these two posts, they kind of fit in there, just about, maybe not quite enough, but there we are. So I can ignore that part, if you like, of the whole of this area here, because it's all filled with wood. It's not quite. There's a 3 centimetre gap there, so we might have a little, have to fill that small pool there as well. But let's just see what the big numbers tell us. So if I ignore that part of the area, then this width is about 51 centimetres. So here's what I'm trying to do. Here's my area. It's 51 centimetres that way. What's the other one? It's about 36 centimetres. So I know the area I'm trying to fill. Now the volume obviously is going to be this area multiplied by the depth I need. Well, 51 times, what is the depth? Let's say I need to go definitely below the wire. In the diagram I used from the Instructables website, it said about halfway down the second frame, I think, so which gives us about 13 centimetres of depth. So about 13 centimetre deep bat. So let's write that down. So 13 centimetre depth. So the volume I need in cubic centimetres is going to be 51 times 36 times 13. Well, 51 times 36. Well, 50 times 30 is 1500, and 6 times 50 is about 300. So that's about 1800 times 13, which is 1800. Well, 18,000 would be 10 times 1800. So 18,003 times, say, 2,000, about 6,000. So it's about 6,000 plus. What did I say? 18,000. So that's 24,000. So it's about 24,000 cubic centimetres, which is the same thing as 24 litres. And it's all approximate. Yeah, I'm not. If I go down an extra centimetre or up an extra centimetre, I've got plenty of room to play with. It doesn't matter. It's not going to affect the final wedging ability of this table. So 24 litres of volume to fill. Not sure you can see that. Let me hold it up to the camera. There we are. That's the calculation so far. I may have missed out a few decimal places, but I don't care. So, and also, yeah, we do have this little area here. Let's just double check. It doesn't look very big. It's, what did I say, 36 by, that should be about 9 or 10, so 10, 360 by 3 centimetres. That's about 1,000 cubic centimetres. So that's about a litre there, which I've ignored. But a litre compared to 24 litres is less than 5%. So again, the variability is so great, I'm not going to care about that. The 24 litres is fine. I think I used 22 litres on the previous one, and that's been okay. So I'm happy with that calculation. Now, how much plaster do we need for 24 litres of volume, or ending up volume? Because plaster and water, they mix together. They sort of go into each other. So you can't just add them together. It's not like 12 litres of water and 12 litres of plaster. That won't work at all. Actually, what I found when I did the previous one was if I've got a volume V litres to fill, V litres, I need 1.2 times V kilograms of plaster. 1.2 times V. So if I had 1 litre to fill, I'd need 1.2 kilos of plaster. And also 0.7 times V litres of water. So if I needed to fill 1 litre, which isn't very much, as I say, it's just that bit there. If I needed to fill 1 litre, I need 1.2 kilos of plaster and 0.7 litres or 700 cubic centimetres of water. So, which is always sort of adds up to 2 times V, 1.9 times V to get the volume. So they definitely, the plaster and the water mesh together to the point where you can't add up the volumes. If you see what I mean. So anyway, if I want 24 litres, how much plaster do I need? Well, 24 times 1.2 is it's 24. Oh dear, let me get my calculator up. Right, cheating now. 24 times 1.2 is 28.8. Let's call that 29 kilograms of plaster. There we are, that's that one. And the water is 24 times 0.7, which is 24 times 0.7, 16.8. Let's call that 17 litres of water. So I need 29 kilos of plaster, that's a lot, and 17 litres of water. That's a huge amount to do in one go, because I don't have a mixer, an automatic mixer. I'm going to have to do it all by hand. So I think actually I should do that in 2 goes. You can do 2 loads. I think you can do several batches of plaster, because plaster sticks to wet plaster. So I'll mix a batch, pour it in here, and then that will dry pretty quickly. But while it's drying, while it's drying, I'll mix up the other bit and score the back of the first one while it's still quite damp. Pour that on top and it should stick to it. So we'll get the equivalent of 1 thick slab. But I don't think I'll be able to mix that much up and pour it all out safely. That's the other thing. Pouring plaster, as I just discovered with the first wedging tables, is an art in itself. You have to get it to just the right point, a little bit before it's starting to set, which is hard to judge anyway. And then you've got a few seconds, really, to be honest, to pour it out while it's still liquid enough to. Because if you think this is going to be upside down, the plaster's got to flow into this gap here, these 4 gaps here, so it fills these corners and covers all these bits. It mustn't be. It's got to be quite liquid at that stage, but it very quickly goes from quite liquid to quite solid, and it's a bit scary. So. I think I'll be able to manage it better if I do it in 2 loads than 1. So, yeah, that's too much. So let's do that in half. So 29, half of 29 is 14 and a half, isn't it? So let me make a note to myself. So 14.5 kilos, so 2 times 14.5 kilos of plaster. And 17 divided by 2 is 6.5. 6.5. No, what am I talking about? 7.5. 8.5. 8.5 litres of water. Right, twice. And I reckon I can manage 14.5 kilos. So remember, 1 litre of water is also weighs a kilogram. So that's 23 kilograms or so of water, of stuff to move around. And 23 kilos, that's 2 bags of clay which you're moving around with your hand. I know it's liquid, but it's still heavy. Then I've got to lift them both up, lift that all up and then pour it in. So it's still a fair bit of stuff to cope with. I don't see why we couldn't do this in 3 batches or even 4. I don't have enough experience to know whether that's going to work or not. I don't see why not. If that's just too much for you. And if this were a much bigger table, this could be twice the size, I guess, then I think I really would have to do it in several more batches than just 2. So let's get on with mixing up the plaster and water. Well, no, next step is to prepare the frame to receive the plaster. Let's do that next.